The word looks simple. We see a rock, we see a glass of water, but underneath it's a chaotic, swarming, beautiful mess of particles. The problem is you can't count them. You can't sit there with tweezers and say one atom, two atoms. You'll be there until the sun burns out. So, how do we talk about the sheer magnitude of microscopic? We invented a bridge, we call it the mole. Think of a dozens, it's just a word for 12. Convenient, right? It saves us from saying 12 donuts. Well, a mole is just a dozen for the universe. It's specific number. It's a specific number, 6.022 into 10 to the power 23. Why that number? Because it's the number of atoms in exactly 12 gram of carbon. 12. It's not arbitrary, it's a scale. A way to connect the tiny, invisible atom to the gram scale world we actually hold in our hands. Here is the beauty of it, the molar mass. If you have one atom of carbon, it has a mass, a tiny, insignificant mass. But if you have a mole of those atoms, the mass just clicks. The mass is atomic mass unit. For a single atom becomes the mass in a gram. For an entire mole of them, it's a perfect bridge. 1 mole of carbon is 12 grams. 1 mole of oxygen, 16 grams. Nature is remarkably tidy if you know how to look at the books. People get scared of the math. They see 6.022 into 10 to the power 23 and their eyes glaze over. Don't let it. It's just a conversion factor. It's a way of saying, I want to know how many particles are here without having to count them. We are just scaling up from the microscopic to the macroscopic. It's like looking at a map. You don't need the whole world in your pocket to understand the route. You just need the right scale. That's all the mole is. It's our way of understanding the scale of reality. The universe is built on these tiny fundamental pieces, and if you understand how to count them in groups by mole, you can predict how the world behaves. It's not magic, it's just bookkeeping for the cosmos, and it's absolutely wonderful. Thank you.